There you go. So, again, you do need a calculator. Make sure you have a calculator. If not, make sure you borrow one, please. So, if I have tangent of 30 degrees, okay, that's about 0.58. So if you plug that into a calculator, it's about 0.58. Then it follows that if the tangent of an acute angle is 0.58, then that angle measure would have to be 30 degrees. Okay, so the inverse of a trig ratio is finding the angle. Okay, so we're finding the angle measure given the trig ratio. So instead of finding the side of your right triangle, we're going to use our ratios of sides to find the angle instead. So most of you will use the second or shift key on your calculator for the inverse function. Okay, so you're going to use that second or shift key to find the measure of the angle. Okay, so take out your calculator. So on your calculator, so on mine right here, if you want the inverse, okay, you're going to press that second or shift key and say I want sine inverse. You'll still press that sine button. If you notice right above the top, it says sine and it has to that negative first, okay? That means inverse and it should pop up like that, okay? So that's the button we're going to be using to solve for these angles, okay? And it does the same thing with cosine and tangent. It has that little negative first above it. That means inverse. And all of you should have that on your calculator regardless of what mine looks like. On some, however, it won't pop up on your screen. Okay, it won't pop up on your screen. Instead, you'll have to type in your ratio of sides first, and then you'll type in second and press sine inverse. Okay, so when we take the inverse, so if I have sine of angle A, okay, remember our angle is always attached to that trig value there, and that equals x. Okay, then sine inverse of x will equal the measure of angle A. So honestly, you can just think, I just need to switch A and x. Okay, if you switch them, that's taking the inverse. Okay, they just switch. Now, the actual way it happens, if I have sine of A is equal to x, I can bring in that sine inverse on both sides of my equation. What that does is cancel out both of those on that left-hand side. Okay, so that inverse will cancel out with that sine value. And I'm left with A on that left-hand side is equal to the sine inverse of x. Okay? So you're bringing in that sine inverse to both sides, cancels out on one side, it stays on the other. That is true for cosine and tangent as well. Okay, it's just cosine inverse with cosine and tangent inverse with tangent. So looking at some practice problems here, I think you'll find this a little bit easier than what we did yesterday even. So we want to find the indicated angle measure. In this case, we want to find A. Okay, so we're looking for this angle here. So from that angle, we still need to identify the sides that we have, just like we did yesterday, to figure out if I'm using sine, cosine, or tangent. Okay, so if I'm looking here, I have this side of 18 and this side of 27. Okay, so from that angle A, 18 is across from it. That means it's the opposite side. This 27 is opposite that 90-degree angle, so that is your hypotenuse. So I have O and H. I'm using SOHCAHTOA on my left-hand board over there. That is sine. So I'm going to use sine. I went from this angle here. That's angle A. That's my variable. I don't know what it is. It is equal to that ratio of sides. So that opposite side is 18 over the hypotenuse is 27. Now I need to solve for that variable A. Okay? When I'm solving for an angle, or there's a variable for your angle, you need to bring in the inverse. Okay, so we're going to bring in sine inverse on both sides of that equation. Okay, they cancel out on the left-hand side. So we have A is equal to sine inverse of 18 over 27. Okay, from here, we're just going to plug it into our calculator. Okay, so here's my calculator. If you have one like this, again, you can just type it in straight across. So to get sine inverse, again, you need to press second. We'll press that sine button. Make sure it shows up with that -1. And then we're going to type in our fraction there. So 18 over 27. And I'll end my parenthesis. Press equals. Okay, so the measure of angle A you should get is 41.8. Okay, so A equals 41.8. And I can write that up here. And that is in degrees. Okay, we're finding an angle measure. So it's 41.8 degrees. Now, if you have a different type of calculator, you're going to first type in your fraction. Okay? So here, first you're going to type in your fraction. You have 18 divided by 27. Okay, you're going to press equals and get a decimal. Then you're going to press your second button and then your sine button, and you should get your answer. Okay, so with this type of calculator, you just, again, want to do it backwards. So whatever's in your parentheses, type in first, press equals, and then you can say the sine inverse of that decimal. Thank you. Questions on that first problem? Okay, looking at number 2. This time we want to solve for angle B. Okay, so we're solving for B. That's what I'm going to circle here. Next, I need to identify the sides. Okay, so I have a side of 20 and a side of 6. So from that angle B, if I go across, I'll hit that side of 20. So that means it's the opposite side. From this angle B, I have a side that's next to it that's not the hypotenuse, right? Side next to that's not the hypotenuse. So that is your adjacent side. So I have O and A. And in SOHCAHTOA, it's that TOA part. Okay, so I'm going to use tangent. So we have tangent of the angle you're working with. That is angle B. Again, that's my variable. It is equal to that ratio of sides. O is 20 over A is 6. Okay, again, I need to bring in that inverse since I'm solving for an angle measure. So tangent inverse to both sides. They cancel each other out over here. So I have B is equal to tangent inverse of 20 over 6. Okay, make sure you can plug it into your calculator correctly. Okay, so second tangent, 20 divided by 6. Especially if you have a different type of calculator, make sure you can plug it in correctly. You should get 73.3. Okay, so measure of angle B is 73.3 degrees. Questions? All right, try number 3. Do number 3. So you should get cosine as the trig ratio you're using. You have the adjacent side and the hypotenuse. Then I could take the inverse, both sides, and get that angle measured to be 78.5 degrees. Any questions? All right, so on the back, we can solve a right triangle, okay? With all of the different things that we've learned so far in Chapter 8, we can solve a right triangle. So that means you're finding all of the angles and all of the side measures of that right triangle. Okay, you'll be given enough information where you can find all of that. So in the example below here, I have this table for angles and sides. Okay, I need to find all three of each. So right off the bat, I have the measure of angle x. I don't know that one yet. I also need the measure of angle z. What's the measure of angle z? 90. Okay, and then I also need the measure of angle y. And again, I don't know that one yet. With my sides, I have side xz. Okay, that side is 5. I also have side zy, so I'll write zy in that table there. That is 9. The last side here is yx. And again, I don't know that one yet. So when you're given this right triangle, you'll have 3 measures given to you already. Okay, it could be 2 angles in one side, or it could be 2 sides in one angle. Okay, you'll have 3 measures. You have to find the other 3. So in this case, if I have a right triangle and I know 2 of the sides of that right triangle, how can I find the third? Do you remember? Pythagorean theorem. So I can do a squared plus b squared equals c squared. Okay, so when you're solving these right triangles, you can apply all of the stuff that we've learned so far. So if I have 2 of those sides, I can just use the Pythagorean theorem to find the third. Now that third side is the hypotenuse, right? Okay, so that's going to be your c value here. So I'll have 5 squared plus 9 squared is equal to c squared, or I label it as h, so h squared. Okay, so I have 25 plus 81 equals h squared. I have 106 is equal to h squared. Okay, I'm going to plug this into my calculator and just get a decimal for solving a right triangle. Okay. So h should be about 10.3 because you want to take that square root of both sides. Okay, so that's your side yx. Now when you're solving these, you do want to make sure your hypotenuse should be your longest side. Okay, 10.3 is my largest side. The other 2 are shorter. Now I have to find those other 2 angles. Okay, so I have to find angle x and angle y. So if I go from angle x, we're going to do what we did on the front. If I'm solving for an angle, we're going to use our inverses. From angle x, if I go across, that's the opposite side, right? This side over here is adjacent. So I have O and A. That's tangent. So I'm taking tangent from the angle I'm working with is x is equal to the opposite side 9 over the adjacent side 5. Okay, again, if I'm solving an angle, for an angle, you need to take the inverse. Okay, so I'm going to take the inverse of both sides so that they cancel over here. And x will equal the tangent inverse of 9 over 5. And it is 60.9. Okay, so the measure of angle X, we can write in our table here as 60.9 degrees. Okay, now we want to do Y. Okay, so from this angle now. From this angle, I have a side opposite, and I have a side adjacent. So again, I'm going to use tangent of Y. Now your fraction for this one is just going to be opposite. So I have the opposite side is 5 this time, over the adjacent side is 9. Okay, that's why I didn't label them before, because I knew I had to switch to different angles. And again, I want to take the inverse so that I get Y is equal to tangent inverse of 5 over 9. Okay, and Y should equal 29.1. Okay, so we have 29.1 degrees. Now there is an easier way to find Y. Okay, there is an easier way to find Y. All of your angles in your triangle have to add to 180. So if you have 2 of your angles already, you can subtract them from 180 to get your third. Okay, so if you don't remember that, that's fine. However, we will come back to that in a different chapter. For what? Use what equation? You don't have to use special right triangles. Okay, questions on how I solved this right triangle number 4? All right, I want you guys to try number 5. Okay, so fill in your table with what you already know. Okay, and then find that other angle and the other 2 sides. Okay, so this one you can't use the Pythagorean theorem until you find another side. Make sure you guys are using SOHCAHTOA. Okay, it's what we did yesterday to find one of those other sides. So use SOHCAHTOA. Okay. Use your trig ratios to find one of your other sides. but you want to multiply by 30. Now, do you want to find this side, or do you want to find that side first? Okay, so what side is that? But this is opposite, so what side is this? You have the same thing, right? If you go across, that's one side. Opposite.
I think
Okay.
from there.
That would be your hypotenuse, right? If I have
Yeah.
one
I
eight.
can do this. This is one.
Yeah. Okay, sine is 33. That would be angle. Where is sine 33? I did it, right? And from here, you should have times sine of 33.
33.
Then you multiply both sides by 8.
Rounded to 4. And then you just have to take this square and get you what's right, then you add that together. So you get 465.60. It'll match. Well, they each have.
You are wrong.
No, that's right. 29.4 for PR. That's right.
All right, I'm gonna go through number 5.
Oh, I don't know.
I got rounded. You rounded that to 3.
That's the hypotenuse. So you should have done 16 divided by sine of 33.
59 what?
16 divided by sine of 33 to get your hypotenuse.
Sine of 33.
Yeah.
I did 10. Wouldn't it be 10?
No. This one would be tan. This one would be tangent. The hypotenuse would be sine.
I only did 1.
Oh, that's why. That's why. Because you did. Yeah, that's fine.
Didn't you say?
Yes, you can do the Pythagorean here with that one. Yes.
I'm not sure I understand.
Didn't understand.
I know. Siri yelled at me.
What's going on, Siri?
All right, so going through number 5 here. The measure of angle P. You can take 180 minus 90 minus 33. That is 57. Okay, then the measure of angle Q is 90. And the measure of angle R is 33. For your sides, PQ is 16. QR, we don't know yet, so I'm just going to write QR. And then we also need RP. Okay, so we need the two sides. The answers, QR is 24.6. And RP is 29.4.
explain those?
Yes, I'm going to explain them. So when I'm looking for a side, I usually label them with a variable. Okay, so say I want to find QR. Okay, I'm going to label that as X. I'm going to go from this angle right here because that's the one that was given to me, so I'm just going to use it. Now, if I want to use my SOHCAHTOA, my trig ratios, okay, I want to use trig ratios to solve for those sides. So opposite would be 16. And then I have this side here is adjacent. So I have O and A. I'm going to use tangent. Okay, so I have tangent of the angle I was working with. So I'm going to use 33. That's not my variable, so I need to plug in the angle. Okay, that is equal to your ratio of sides. Your opposite is 16 over your adjacent is X. This is what we did yesterday. Okay, you're going to solve for X, so you're going to multiply both sides by whatever's in the denominator. They cancel out on the right-hand side. So you have X times the tangent of 33 equals 16. Again, you're trying to isolate your variable. You're trying to get it by itself. So you're going to divide both sides by tangent of 33. Cancels out over here. So we have X is equal to 16 over tangent of 33. And you can plug that into your calculator. Okay? When I do that, that was QR, you should get 24.6. Okay? For RP right here, you can label it as Y, you can label it as H, you can label it as C. Doesn't matter what you label it. Now, two options. You can either use your trig ratios or you can use the Pythagorean theorem. Just be aware with the Pythagorean theorem, you're going to get a different rounded answer. It'll be a little bit off. Okay, so Pythagorean theorem, you take 16 squared plus 24.6 squared equals y squared. Okay, you can do it that way. That's fine. I'm going to show you the trig ratio way. So if I'm going from this angle again, I'm going to use the answer I didn't round for. Okay, so I have this side is still opposite. Now this side over here, that y that I labeled, is the hypotenuse. Okay, so I have O and H. That's sine. Okay, so I'm taking sine of the angle that I went from is 33. That's equal to the opposite side is 16 over the hypotenuse is y. And again, when I'm solving for a variable that's in your ratio part, you always multiply both sides by whatever's in the denominator. So multiply by y. So they cancel out over here. So we have y times the sine of 33 is equal to 16. We want to divide both sides by sine of 33. So they cancel out on the left. So y will be equal to 16 over the sine of 33. And you should get 29.4. Okay, so again, you're applying everything that we've done. It's not just using the inverse just because you want to use the inverse. You only use that inverse trig ratio when you're solving for an angle measure. Okay? When you're solving for a side, you're still using trig ratios. You just don't click the second button to make it an inverse. Okay? You just need to solve for the variable within the ratio like we did yesterday. Okay? Otherwise, you can use the Pythagorean theorem if you have two sides of that right triangle already. Any questions? Yes.
If we do, like...
If you're a little bit off, I won't mark it wrong.
Oh.
Other questions? All right, then work on that assignment, please.